Thanks for joining. My name is Sahm. Call me Kim. I'm a sales engineer and Kubernetes evangelist at D2IQ. And we talk today about GitOps. What is GitOps? Why we need this? And what it brings us in our Kubernetes journey and cloud native journey. First of all, we're talking about cloud native. I believe most of you are using cloud native and Kubernetes ecosystems. Please, hands up, who's using Kubernetes in production? Mostly all. Okay, this is really great. So then you are on the right journey. Why the people are using Kubernetes or why this cloud ecosystem is growing so much? Because we would like to dive in these digital agility. We like to use open source. The open source ecosystem is growing and growing. Also during the time like data privacy, GDPR, DSGVO, how we call it in Germany. So we need to understand what's inside of our products, what's inside the tools, and what the tools we are using are doing with the data which is stored in. So open source is very helpful because it's open, like the name is. And we are able to see what's inside of the products. Is there a backdoor? Is there something which sends our data to the United States, to the NSA, to the Chinese, to the Russia, and you name it? Then, of course, Kubernetes is there because we need this portability. The idea why Kubernetes was born is we need an abstraction layer to abstract our application from the infrastructure. If we build an ecosystem, if we build our application which runs totally on Kubernetes, we don't care about the infrastructure. Our application is portable. Our application runs everywhere where our Kubernetes runs. In cloud, on-prem, in edge, we don't care about this. And yeah, of course, if we say digital agility, all these buzzwords are born. We're talking about AI, we are talking about Agile, we are talking about DevOps, and what does this mean at the end? Because some people had its own idea what agility is. Agility does not mean chaos, and sometimes you have the feeling that blind people talking about colors. So we need to define what these buzzwords means. In the buzzword bingo, we all know what Waterfall is, the Waterfall approach, the oldest approach, how to design software or build software. We have the different stages, and a stage can only start if the stage before is completed. So this means we have these design, build, test, and deploy stages. It's plannable, but if we run into an error, in our testing stage, we need to fix this bug. And this bug fixing means we go back to our build or to our design stage and rerun our process. And this is very blocking. It's extending our time to market, and we need an approach to be faster, to react faster on errors. And this is the next stuff. Agile was born. Agile was born 2001, I believe. And the idea of Agile is doing this waterfall approach in smaller steps, make it and save the time, save the money at the end, because we have smaller cycles, we have smaller stages. In Scrum, we call it sprints. And if we run into an error in our testing stage, we can fix these error during our sprint, and we are flexible. Our go-to-market, time to market is very short. And then DevOps was built. DevOps, I believe this is the word which is most used at the moment in the market. All companies would like to have DevOps. We are creating DevOps teams, but what does this mean? So DevOps, we have the same idea. What we saw in Agile, we want very short very short cycles to deploy, to develop and deploy software. And the DevOps culture, at the end it's a culture, we need to understand this, brings the devs and the ops guys together, and it's more focused on the deploy part. We are not only checking out how to build software, we are thinking about how to run it, how to operate it. This is this typical approach. You build it, you run it. The devs and the ops guys are closer together, breaking these silos to get the benefits from the dev part also ported to the ops part. At the end, what's really important, we are talking about processes, we are talking about methods, we are talking not about technology. DevOps is not a technology. A lot of people mixing these topics together. The idea is, I would like to move my company to a DevOps approach. So we are replacing VMware by Kubernetes, and now I'm DevOps. Say, no, you've changed the technology, but DevOps is a culture, DevOps is a process. You need to change the mindset to get the benefits of these DevOps approaches, DevOps mindset, DevOps culture. This question I was asked in early March at the Cloud Expo in London. I talked with a guy at a booth, and then we talked about Kubernetes and DevOps, and the guy asked me, okay, I don't have Kubernetes, can I also do DevOps? And yes, of course, because there's no need that you have a Kubernetes cluster to using DevOps. DevOps is the mentality. DevOps, we are talking about what I said, dev and ops together in a table, in the same mindset, removing silos, and focus on ops, how to lifecycle our environments, how to lifecycle our platforms, how to lifecycle our workloads in an, or at the end, automated way, make it reproducible, and make it more error-prone. And now we are enter our topic. We are talking about GitOps. What is GitOps? GitOps is DevOps, and we add our Git to these. And now we have GitOps. GitOps has the idea that we say we are using these culture and the methods DevOps brings in. We are using pipelines and automation, which mostly comes from the dev part of DevOps. The dev guys using pipelines since years. For the ops guys, pipelines and automation is mostly the new thing. The ops guys are a little bit shy and a little bit feared in regards of the automation. Automation, maybe there is something wrong inside, or automation kills my job. This is what we always see. If I talk with the ops guys, in my past I've run in ops teams since, I don't know, 10 years. And I see always the same problem, the same fear. Automation kills my job. I say, guys, automation will not kill your job. Automation will make your job interesting, because what are we automating? The boring stuff. The boring, time-consuming stuff. Most operation teams are under pressure. It's like the fireman. They running to the biggest fire and try to fix it, and then running to the next fire. And automation helps us to create a default and standard how our environments looks like, and help us to save our time, do it in an automated way, and step away from these manual stuff. I don't care. I don't know. I don't like to install a 200 Linux server with an ISO image, and then each system looks a little bit different. This is what we would like to avoid. And GitOps brings in our central component, and this is Git. Git is our single source of truth. We are using this for development since years. Developed by Linus Torvalds somewhere in the 90s. And it's a version control system. And the idea is all our declarative description of our environments are stored in Git. And then we are using pipelines and automation to build the things we defined in Git in our environments. No manual changes on our systems. Git is the single source of truth. On the other side, Git is also the baseline for our documentation. This is what the developers always said, code is documentation enough. In this case, yes, because I have the description of all my target states, of all my target systems, and say, this is what I expect in my production system. This is what I expect in my deployed setups. We are talking about cloud native. We are talking about Kubernetes. At the moment, we see all the people are using Kubernetes. The companies have to understand, oh, Kubernetes brings in a big benefit. We should use Kubernetes. But if we're talking about Kubernetes, we're talking mostly about cloud native, because Kubernetes is a container orchestrator. Nothing more, nothing less. It's doing orchestration. And is orchestration enough for running a containerized platform in production? No. So we need to think about additional topics. We need to think about, first time, how can we create Kubernetes clusters? And how can we lifecycle Kubernetes clusters, which means updates and scaling? This is not a big issue. We have kubeadm for these. Or the most easiest version, go to a hyperscaler and say, hey, AWS, give me an EKS cluster, and I'm up and running in 15 minutes. I don't care about the other topics. And then I realize, okay, for second-day operations, for enterprise needs, we need to think about what's with monitoring, what's with logging. Maybe you have multi-tier logging. Maybe we would like to have a user authentication in place, because the flat Kubernetes RBAC methods are a little bit, it's nice for small clusters, nice for startups, nice for labs, but for enterprise use, I would like to have the control for authentication, authorization. So we need to think about this stuff. Lifecycle, the platform as well as the operation. And what is with persistency? Kubernetes is designed for running stateless applications. This is easy. Starting a stateless application, the pod comes up, system is there, application is working. But if we check our applications, there is a state somewhere. We are talking about a database, we need a file service, and all these topics are addressed to our teams. They are handling these too, but Kubernetes doesn't care it. Kubernetes says, it's not my part, I'm a container orchestrator. So, for these, we have the Cloud Native Computing Foundation ecosystem. We see in this ecosystem there are a lot additional tools available. They are designed for handling these challenges. There are tools for monitoring, there are tools for logging, there are tools for backup, etc. And now we realize, okay, I need to pick up my tools I need for my cluster, for my use cases, and it's not only Kubernetes what need to be handled. So we need also to handle all the other tools. These needs also lifecycled, integrated, configured, and so this is a complex setup. And maybe we have not only one cluster, maybe we have a lot of clusters. And we're just talking about platform. We are not talking about our application at the moment. So what does it mean? We need an automation for this. We can do this in a manual way, jumping around on an SSH shell and installing packages and configure stuff via command line and deploying stuff via Helm. But we need to step away from these manual approaches. We want to define these stuff in our Git and use automation and use a pipeline to deploy our changes. And if we run an update, if we run a configuration change, we need to change it in our single source of truth, and this is Git. No changes on the system, always in Git. So let's create a use case. The example is we would like to deploy a Kubernetes cluster. We need infrastructure for running our Kubernetes cluster. We would like to deploy it via kubeadm, and we need an application on top of these. So, we start with infrastructure. Infrastructure, next buzzword is born, infrastructure as code. Infrastructure as code means what the name is program. We defining our infrastructure in Git, and a tool and a framework is building this infrastructure. Yes, of course, this is infrastructure as code requires an infrastructure which is able to be addressed by an API and brings in this automation flow. So, for example, if you run workloads on VMware, there's a provider available. If you run in a public cloud or in a private cloud, OpenStack, whatever, there are providers available. If you run on bare metal, maybe there's also a provider in place. In this example, we have Terraform. I believe most of you have heard about Terraform. Terraform, developed by HashiCorp, is open source, and the Terraform is built to create infrastructure which is defined in a Git in a declarative way. So, how could this look like? An example of infrastructure as code. I have my Git repo, and then I have different files created. They are controlling my deployment. The blue stuff is an environment variables. If I would like to deploy different environments, I would separate the environment specificas in different environment variables. I have the green one, my Terraform. What is the right term? I would say playbook for these. Not sure if it's the right term. So in these green files is the logic included, the Terraform pipelining information, what should be done during this deployment. I have an example for a GitLab CI because I like GitLab CI, but it's working with all the other pipeline tools as well. If you use Jenkins, use Jenkins. And then also important, git ignore. If you work with Git, you should think about to have a git ignore file in every repo in place, because the idea of Git is a version control system. Data which is pushed to Git is stored there forever until you remove the repository. And this happens so often that people commit data to Git which is sensitive, maybe secrets, maybe an AWS access key, and other people find this information. This is the most common hack at the moment. Hacker groups scanning public Git repositories and scanning all the commits and checking out if someone committed an AWS access key and secret key, and then the hackers use this key to spin up a lot of Bitcoin miner or whatever is in hype at the moment, and then at the end of the month you get your AWS bill for $500,000. Perfect. And it's a true story. This happens so often. And so the git ignore could prevent us to commit such sensitive informations based on files. So if you, for example, you have a license key, this is handled in your environment during the deployment, during your testing. In the git ignore file should be the git ignore file should be prevent that you commit such information, such files to the Git. If we check out what the files means, in this example, I've created an Terraform variables file which defines my my variables. For example, here's my definition for my new cluster. I would like to deploy 3 master nodes and 6 workers. And the master node and worker node sizing, which flavor should be used there. And if I would like to create another environment, I would like to create a prod environment or a staging or you name it, you need just to create an own vars file and define the variables which are needed for this specific environment. And these variables are used by the Terraform playbooks, the Terraform scripts. So Terraform, in this example, this is an example how to create a Linux machine in Azure. And you see at the important points, I'm pointing out to the environment file. So master node count, it's based on what is set in the environment variable. This will be used in this example. We have the same for our GitLab CI at the end. GitLab CI says we have a stage lab, and the stage lab run the job is triggered if we change something in this environment variable, and then at the end the pipeline starts the Terraform init and runs the apply, which contains the all the Terraform playbooks and points to our used environment variable. At the end, that's all. That's an easy example for how this pipelining should look like. Example for git ignore. If you use an vault file or something like this, you should be for your vault secret. You should be sure that you're not committing files like these to Git, because what I said, it's committed to Git. It's there forever. So this is the short example how Terraform could looks like, and it's what I said. It's really important. Don't make your code. If you write automation, make it as modular as possible and avoid hard-coded facts. So make your code reusable. So it makes no sense to create repos for deploying an environment with a lot of hard-coded facts, and then you need to deploy a different environment, and then you copy your playbooks, and then you change it again in your code, make it modular, make it reusable. So we have infrastructure. Next step is we need an automation to deploy Kubernetes on top of these. This example is an Ansible example. The structure is like the same. We have a repo. We have our group vars. The group vars are pointing to our environments. We have roles in place. They're handling this. We have our GitLab CI in place, and we have our deployment script. And it's not in Terraform, it's not an Ansible session. This is why I'm cutted these Ansible informations here. If you are interested to discuss this, come to our booth later, and then we can discuss this a lot. So you see, the approach is the same. We have the different environments. We have roles. There is our logic inside. We have our main playbook, which includes all the roles they are needed, and then we have a pipeline, and the pipeline runs this information in a complete workflow. It looks like this. We have our pipelines in place, we have our files in place, and if I would like to scale my worker nodes from 6 to 8, I change my worker node count in my environment variable, push it to Git, merge it into the right branch. The pipeline is triggered. The first pipeline built my infrastructure, generates my inventory, hand it over to the Ansible pipeline. The Ansible pipeline deploys the workload on top of the servers, and then here we go. There is a typo. I realize it. Yeah, cluster is ready, and it ready, and I inform the administrator. I have scaled my environment in my default method. I'm used my standard, and the important thing, I have no manual tasks. I have no manual changes in my systems. Each system looks like each other system. Now we need software on top of Kubernetes. We would like to deploy a Helm chart or an application based on Kubernetes manifests. And for these, I would like to introduce another tool. It's called FluxCD. FluxCD is part of the CNCF ecosystem, and it's very lightweight automation or continuous delivery for Kubernetes workloads on top of Kubernetes. So the idea is, I have a Flux controller. The Flux controller has a source controller. The source controller is pointing to my repos where my workload is stored in. And I'm creating pipelines in Flux. They will observe my Git repository. And if there is a change, the delta will be rolled out to Kubernetes. Flux install, very easy. It's a binary. It's a single binary. Download it, Flux install. Flux is installed to our Kubernetes cluster. And then we create our first pipeline, create a source. In this example, it's pointing to GitHub repo pod info. Please watch the master branch, and please have an interval of 10 minutes. So every 10 minutes, Flux checks the status. Is there something to do for Flux? We have our customization backend in place, and then after the first run, we see our workload comes up. So this is no rocket science. What does it in? So what does it in the background? What I said. We are creating a pipeline. We inform FluxCD, Flux, please watch this Git repo in this branch and maybe this subdirectory. And then Flux checks every whatever we set in our interval, checks the Git repository. And if a developer push code to this Git repository, Flux detect, oh, there's something changed. Okay, I need to check what is the delta, and I need to deploy the delta to our Kubernetes cluster and inform my user pipeline is done, workload is up and running. If something goes wrong, Flux triggered a rolling upgrade. If something goes wrong, Kubernetes takes the break and say, "Ha, deployments are not coming up. Something is strange here. Administrator or operator, please have a look on these." How could we fix it? We fix it in Git. So we know, okay, something is wrong with our deployment. That's why our CD pipeline is not able to roll it out. Problem is in Git. So we are fixing the problem in Git, or we are rolling our last push or last commit back to a stable version. Push this to our Git branch. Flux detects, oh, there's something to change. Delta is fixed. Application is up and running. And you see, it's very easy to operate the complete stack from infrastructure until your application by using GitOps, by using CI/CD pipelines and automation. And the important thing is, this never change any stuff in your systems in a manual way, because the pipelines are some objects are in control by the pipeline. If you change it manually, what could happen? You're operating your system. Something is wrong, and you fix it manually. You jump in via SSH to a system and do stuff manually. Okay. Next time the pipeline runs, maybe they fail because they see, okay, there's a dependency which is broken, something is strange here. Or the pipeline say, this file contains informations that I don't have, so I will revert these changes. So your manual changes are reverted, and you roll out again your broken state, and then, surprise, nobody can remember, okay, what have we done last time, why it's broken. So I believe all of you, they are from an ops side, know this example perfectly. This is what happens if your systems are not equal, your systems are fixed in a manual way. It makes no sense. So that's why all changes, if you use pipelines and automation in a GitOps approach, please, all changes are done in Git, never on the systems. Delete all your SSH keys. Say, right, the ops guys, don't jump on the systems, fix it in the pipeline, fix it in the code, fix it there. Don't jump to the systems and don't touch the systems. It makes no difference if we are talking about an operating system layer or on a Kubernetes application layer. Besides this, what is with secrets? So we talked about secrets, and we talked about it's a stupid idea to push secrets to Git, but how we can handle this? What is the solution how to can handle Git? Because it makes no sense if my application needs a secret because I need SSH keys or passwords or something like this. But if they are not stored in Git, I need to store there in another place. And for these, at the moment, the de facto standard is Vault. Vault is also developed by HashiCorp, is available in an open source version, or let's call it freemium, in a free for use version, and then as well in an enterprise version if you need more enterprise stuff, features, whatever. And Vault is a store and secret store where you can place all your passwords, all your keys, and then the pipeline has a handshake token to get the information, the sensitive information from the Vault store during the pipeline run. This is the way how we should handle secret passwords, sensitive data. Never store this in Git. And yeah, recap, what have we done? We have understand that DevOps and Agile are not technologies. That's methods and culture, and it's really important to understand this. Single Git is our single source of truth in GitOps. All the information must be stored there. Git is our single source of truth. Nobody else should data be stored. We have a declarative way to describe our landscape. Not only Kubernetes workload, there we have this declarative approach since it's born. For example, you have Helm in place, then you have a declarative way to define all your configurations in these values YAMLs. And this is the same approach we would like to use for infrastructure as well. Definitely, we need automation and we need CI/CD because we don't want to jump on systems and do stuff in a manual way because it's generating a lot of errors and each system, each deployment looks different. It's not reproducible, so at the end, makes no sense. If you write automation, if you write pipelines, if you call it whatever you want, make it reusable. Don't hard code all information in your playbooks, in your roles, in your salt states. I believe state is the right term for salt. Make it modular, make it reusable, use variables, and check out which variable should be stored in an environments file and which variables should be stored in a global file, because it makes your life easy. You just need to change this one variable, and it's working for all. No, never manual changes. I believe I've pointed that out a few times this talk. And then please don't store secrets in Git, because that could be your death. In this case, we are a little bit early in the time. Do you have some questions? Okay. Perfect. Then, thanks for your time, and have a great day. See you.